Okay, today we're going to talk about addition and subtraction of algebraic fractions. So that's section 5A of your text. And it starts off by saying algebraic fractions are just like normal fractions except they include pronumerals. So pronumerals you've met before, that's when you use letters to stand in the place of numbers you don't know the value of. Okay, this means you just apply the usual arithmetic rules that you learned for numerical fractions in first form in conjunction with simplifying algebraic expressions. So there's nothing new, no new rules other than remembering that a pronumeral is just like a normal number. It just looks a bit more confusing because it's a letter instead of a number that you're used to seeing. Okay, so it's probably best to think it's a number in disguise. It's doing the work of a number, it's just not as obvious. Okay, the second paragraph says to add or subtract fractions, you must first have common denominators. They need to have the same value on the bottom of the fraction. They need to be talking about the same kind of fraction. And once you've got common denominators, you simply add or subtract the numerators, the top number, keeping the same denominator, the same bottom number. Okay, it's best to find the lowest common denominator. You can add them as long as you've got a common denominator, but if you don't find the lowest common denominator, you're going to make things a bit more tricky for yourself. If you can find the lowest common denominator as your first step, you're going to make things a lot less painful and a lot less opportunity for error. So that should be your goal every time. Okay, let's go through some examples. So the first example in text is 2a on 3 plus a on 6. So hopefully you've got your thinking cap on and you can see straight away, I'm going to go for a common denominator of 6. To get a common denominator of 6, we need to do a bit of work on the first fraction. And we need to multiply it by a fancy version of 1. In this case, our fancy version of 1 is 2 on 2. Multiplying by 1 is not going to change the value, which is good because we need it to be the same value, but it will change the appearance of it. Okay, it's made it into an appearance that's more useful for us. So we've got 2a times 2 is 4a over 3 times 2 is 6 plus a on 6th. So we're talking about sixths. So the denominator is going to be 6, and we've got 4a sixths plus a sixths. So 4a plus a is 5a over 6, 5a sixths. Okay, and that's the first example done. Next example, 5b on 6 minus 2b on 9. It's a bit harder to spot the lowest common denominator, but if you've got your thinking cap on, you would have spotted that it's 18. To get our common denominator of 18, this time our fancy versions of 1. For the first one, we need a fancy version of 1 that is 3 on 3. And for our second fraction, our fancy version 1 is 2 on 2. Okay, so multiplying that out, we've got 5 times 3 is 15, so it's 15b on 18 minus 2 times 2 is 4b on 18. And we have a common denominator of 18, so we're talking about 18ths. And the top is like terms, so we can do a subtraction there. 15b minus 4b is 11b. And there's no common factors there, so that's as good as we can get. That's our final answer. Now let's look what would happen if we weren't quite on the ball and we didn't spot that lowest common denominator of 18. One of the most obvious ones to go for is the multiple of the two, so 6 times 9, which is 54. So if we went for a common denominator of 54, it would work, but let's see how much of a pain it is to do that. So for the first fraction, our fancy version of 1 would be 9 on 9. And for our second fraction, our fancy version 1 would be 6 on 6. Okay, so multiplying that out, we've got 5 times 9, which is 45, and then we've got our b, and that's on 6 times 9 is 54. And for the second fraction, 2 times 6 is 12. We've got 12b on 54. Okay, so we're talking about 54, so we'll put it all over 54. And they're like terms, so we can subtract 45, take away 12 is 33. So we've got 33, lots of b. And it doesn't look the same, but it is actually the same answer as the one above. We just have to do a little bit more work. They've both got a common factor. The common factor is 3, and 3 goes into 33 11 times, and 3 goes into 54 18 times. So we need to clean that up. We can't leave it like that, a bit scrappy. So we've got 11b over 18. So they're both the same answer. But you would have noticed the first way is a lot less pain. So it's in your interest to find the lowest common denominator in your first step if you can. Okay, so you're going to go for the lowest common denominator if you can every time. Let's look at the next example. Okay, the next one, 17c on 20 minus 3c on 5. Okay, so the lowest common denominator is going to be 20. I think you guys are withered enough to go straight to the common denominators with the version of 1 working. So we're going to go both over 20. The first one was ready to go. Here's 17c on 20. But the second one, we need to multiply top and bottom by 4, because 5 times 4 is 20. So 3c times 4 is 12c. Okay, so we've got our common denominator of 20. We can put all over 20, and they're like terms. 17c, take away 12c is 5c. Now, if you left your answer like that, you are going to be losing yourself some marks because they both have a common factor. If you left it like that, it's not in simplest form. You need to look for any common factors, and in this case, lowest common factor is 5. 5 goes into 5 once, and 5 goes into 20 4 times. So we can't leave it like that. It's a bit scrappy. We need to clean it up. Now, if in algebra, if you remember, if you have 1c, the 1 doesn't need to be there. It's invisible. So we'll just have c over 4. And that's the end of that example. We've got our answer in its best format, and we can move on. Okay, next example, stepping it up a little bit, and we've got 4 and 5 as our denominators. So the lowest common denominator is going to be, in this case, 20. Okay, and we'll go straight to that without our multiplication shown. So 4 times what gives me 20? It's 5, so I need to multiply the top by 5 as well. So we've got 15c squared. And for the second fraction, to have it over 20, we multiplied by 4, so the top needs to be by 4 as well. So we've got 2c squared times 4 is 8c squared. Adding those together, 15 plus 8 is 23. So we've got 23 lots of c squared, all over 20. Now, some of you might be tempted to do some work there because you can see 23 is bigger than 20. But if you remember, in algebra, we don't use mixed numerals with pronumerals. Okay, so you'd leave it in that format. You wouldn't go trying to make it into any sort of mixed numerals. Leave it as it is. Okay. All right, second last example. DE on 24 minus F on 8. So the lowest common denominator in this case is going to be 24. The first guy's already ready to go. We can just write him as he is. And the second one over 24, we've multiplied the 8 by 3, so we need to multiply the top by 3, so we've got 3F. All right, so we know we're talking about 24ths. In this case, they're not like terms, so we can't actually do the subtraction, but we do need to make it a single fraction. So we put the numerator all on the top. So we've got DE minus 3F all over 24, and that's its simplest form, and that's as far as we can go. Okay, last one, pretty exciting. And we've got denominators of 6 and 9. So if you remember from the beginning, the smartest move would be to get the lowest common denominator of 18. You could do 54, but that is a world of pain, and you can go for it if you like, but it's not the smart move. All right, so to get to 18, 6 was multiplied by 3, so we go 3, and the best way to do this without making a mistake is to use brackets. So 3 outside of y minus 2. And then for the second fraction, so we've got plus, if we put that all over 18, this time we've multiplied the bottom by 2, so we need to multiply the top by 2, so 2 brackets 3y minus 2. Okay, so we know it's all going to be over 18, and we can expand out the top. So 3 times y is 3y, 3 times negative 2 is negative 6, and plus 2 times 3y is plus 6. Sorry about that. 6y, and 2 times negative 2 is minus 4, and that was talking about 18ths, so it's all over 18. And now we need to look for some like terms, and I can spot some there. We have got 3y and plus 6y, they're like terms, so we can add those together. That is 9y. And then for our other like terms, we've got negative 6. That wasn't meant to happen. How do I get rid of that? Okay, we've got negative 6 and negative 4, and putting those together is negative 10. And we're talking about 18ths, it's all over 18. And that's the answer for the last example. So you are ready to get cracking on exercise 5i. Check Schoology. I'll put exactly which questions I'd like you to to do there, and have fun. Okay.